So, since we are all familiar with the laws, so let's try to evaluate some questions. So, the first question we have to try as an example here is evaluate 2 log 9 to base 3, then times logarithm of 81 raised to the power minus 2 to base 3, or divided by logarithm of 625 to base 5. Now, options are given. The options are 4. Option B is minus 32. Option C is minus 8. Option D is 16. Now let's quickly give solution to this. The solution to this simply implies that do you believe that I can decide to um, break down this 9? But at first, I would like to give you an hint. Before you could know what to do when it comes to logarithm, first consider the base. The base you are seeing here is 3. If you can express this base and the logarithm in terms of 3, 3, then that means you're almost close to the final answer. Now I have 3, I have 9 here. So that means I can break down this 9 down to 3. But suppose you have 3 here and there's a 9 here. That means you have to break down this 9 so that you have 3 and 3 together. So the same thing here. If I have 3 here, that means I have to break down this 81 to 3. So that's 3 raised to the power of 4. And in this case too, if I have 5 here, I have to break down this 6 to 5 to 5 raised to the power of something. So you have to express this 6 to 5 in index form, and that's 5 raised to the power of that should be 4. So that's how to know how to work with logarithm. So here in this case, I have 2 log base 3. This 9 can be expressed as 3 raised to the power of 2, right? And then times, here in this case, I have logarithm of 3. Then this 81 is 3 raised to the power of 4. But mind you, we have minus 2 there. That's times minus 2 straight up. Then I have logarithm to base 5. This 6 to 5 is 5 raised to the power of 4. That's 6 to 5. Now, trivially, if I apply power law of logarithm in this case, this 2, we multiply this 2 we have here, giving us 4. Then what will I have left? I will have log 3 to base 3. Then times this 4 times minus 2, that is minus 8. Minus 8 will come down. Then I have minus 8 logarithm of 3 to base 3. Next thing is this 4 comes down, then I'm going to have 4 log 5 to base 5. And log 3 base 3 is logarithm of its own base law. You remember, it is 1. Log 3 base 3 is 1. This one is also 1. So whatever I have left now is 4 times minus 8. And that is minus 32. And then divided by 4. So if this 4 cancels this 32, I have minus 8. So minus 8 gives the correct answer to that question. So I hope that is clear. And then we also have another question here. We are asked to evaluate logarithm of 8 to base 2 minus logarithm of 1 over 9 to base 3. Now when you have something like this, the first thing you need to do is consider the base. Like I said, between 8 and 2, which one is the smallest? This is the smallest. So that means I have to break this 8 down to 2, to the smallest value I have here. And how will you do that? You know that will be what? 2 raised to the power of 3. 2 raised to the power of 3 is 8 minus logarithm to base 3. This 1 over 9. This 1 over 9. Remember, from indices, you know what this implies. From indices, that's why we actually cover indices at first. So 1 over 9 simply implies 9 raised to the power of minus 1. Where this negative sign means 1 over, then you have 9 raised to the power of 1. So this and this are still saying the same thing, okay? So then from here, I can decide to consider this base, which is 3. So I can easily break down this 9 to 3 square. So this 3 comes down. I have 3 log 2 base 2 minus, here in this case I'm going to have 9 as 3 square, then times minus 1 that I have there initially. So then log 2 base 2 is 1, so I have 3 left, minus 2 times minus 1 is minus 2. Minus 2 comes down. This minus 2 will come down. You know, I already have a negative sign before, so the minus 2 that is coming, see it inside the bracket here. So I will have just log 3 to base 3 left. And log 3 to base 3 is 1. So whatever I have left now is 3 minus minus 2. Minus times minus is what? Plus 2. So I will end up having what? 3 plus 2, that is 5. So that gives the correct answer to that. So as you can see, the question we have here now is logarithm of 8 to base 2 minus this. So I end up having 5 as the correct answer. So let me try to pick some real question from post-TME. And I'm coming, let me check for one. So I've seen one from here. Now just look at this question. If log 20 to base 5 is equals to x, find x. And the options are given. The options are 1.761, B 1.354, and then C I have 1.861, and D I have 2.549. So here in this case, the solution simply implies that the logarithm of 20 to base 5 is equals to x. So this thing here simply implies that, remember that I gave you one particular law, that's the last law that was stated. So let me show you the law I used. This law that I said, if you have log x base a equals to y, cancel this, whatever you have left is there, and this a will be the base, this y here will be the power, the index. So here in this case, what will I have? Cancel this, so I will have 20. So whatever you have left hand should be this 5 you have here, then raised to the power of what? Raised to the power of x. Now here in this case, it is not very easy for us to break down 20. So I would have preferred the question should have come in this form. Normally this can be solved. X is just equals to logarithm of 20 to base 5. Trivially, what I will just do from here, I can decide to use 5 times 4. Then I will split it up. Like doing it this way, 5 times 4 is 20, then I have base 5. So if I apply the law of logarithm, the addition law, I have log 5 base 5 plus log 4 base 5. So log 5 base 5 is 1. So whatever I have left now is to solve this out. Logarithm of 4 to base 5. And you know there's no calculator, so this can't really make any sense except if this is 25. So the question should come in 25 form. So that means this 25 should be 5 square, and you have 5 raised to the power of x. This will cancel this, then x is equals to 2. So this is how the question is meant to be, not in this pattern. Because if you have something like this now, and you still want to, if you have, this is 20 initially. If you have 20 equals to 5 raised to the power of x, this is where we stop. And you still want to find a way to get the value for x in this case. Without using calculator, you won't be able to get this correctly. Because from here now, the only thing I'll just have to do is to take the natural log of both sides. That's ln 20, and then take the ln of 5 raised to the power of x. So that's all I will do. Then I will have ln 20 equals to x ln 5. Then divide both sides by ln 5 by ln 5. This will cancel this. So whatever I have left now is x is equals to the ln of 20 over ln 5. So whatever I get now should be, I have to make use of calculator no matter, I don't have any choice than to use calculator. Ln 20 over ln of 5. So whatever I have left now is 1.86135, as you can see. So this kind of question, you usually need a calculator. No matter how it is, you usually need a calculator. So there's no way you can easily detect that. Okay, so that's how it works. So let's try more questions. What if you have a question that comes in this form, that which says that evaluate logarithm of 1.5 to base 10, then plus 3 logarithm of 2 to base 10 minus logarithm of 0.3 to base 10. So here in this case, I would prefer you consider the coefficient of the logs. Here, this does not have a coefficient, but this logarithm of 2 to base 10 has a coefficient. So this coefficient can easily go up from the rule of, that's power law of logarithm. So therefore, I end up having logarithm to base 10 of 1.5 plus logarithm of 2 raised to the power of 3 to base 10 minus logarithm of 0.3 to base 10. So when you get here, you notice that logarithm to base 10 is common to everything. So since logarithm to base 10 of everything is common, if I cancel this, I will have 1.5 followed by plus. By the rule of logarithm, positive turns to multiplication. Then I have 2 raised to the power of 8, right? Then minus means divide, then I have 0.3. So mind you, we don't have a calculator to use in this case, but there's a way the option would be. So here in this case, I have 1.5, which simply implies that 1.5 is 15 over 10 times 2 raised to the power of 3 rather, sorry, this is 2 raised to the power of 3, and 2 raised to the power of 3 is 8. This 0.3 means 3 over 10. You see, should the case you don't have a calculator and this is not easy, this is not something easier to do, or possibly you can decide to switch on the calculator. If there's a calculator there, just press 1.5 times 8, then the result you have divided by 0.3. So I'm very sure you usually see the correct answer, or you go ahead and solve this way. So here in this case, I have 15, multiply this, that's 15 times 8 over 10, then divided by 3 over 10. Do you understand that my pattern? So mind you, everything here is still inside bracket, please, no mind. So I have this become this. So I have 15 times 8 over 10, 15 times 8 over 10 divided by 3 over 10, or you just say 10 cancel 10, then you have this over 3, or you just show it this way, anyhow you want it. So I'll have logarithm to base 10 of, by the time you change this division sign to times, what happens? 15 times 8 over 10 times 10 over 3. This goes up and this comes down. So the next thing for us to do from here now is 10 will cancel 10. So whatever I have left now should be logarithm to base 10 of 15 times 8 over 3. 3 here 1, and then 3 here 5. So whatever I have left now is logarithm of 10. 8 times 5 is what? 40. So from the options I have here with me, so from this option here, as you can see, logarithm of 1.5 to base 10, 3 log 2 base 10, and this. So what I got? Logarithm of 40 to base 10. So since there's no calculator to use or 4-figure table, then just stop here. B is correct for that question. Logarithm of 40 to base 10. So this is absolutely correct. So that's how logarithm works most of the time. And then you can still try more questions. You have more questions on logarithm. So let me try to pick one. I also have another one here. Suppose we have this question which says log, find the find this, find logarithm of 1 over 40 to base 10, given that the log of 4 to base 10 is equals to 0.6021. So take note of this kind of question. So yeah, from this case, this is dividing, so I can decide to use the idea I have for subtraction law of logarithm. Take logarithm of 1 to base 10 minus, so just take a step backward using the subtraction law. Share you grab. So log 40 to base 10. So that's how it works. This and this are still saying the same thing. So just try to evaluate this. This is what we are looking for. This is equals to whatever I've written here. So from this case, what's logarithm of 1? That is part of the law of indices. The law of logarithm I actually stated. Logarithm of 1 is always 0. Which says that this simply implies that this 1 is 10 raised to the power of 0. The 0 comes, so that's 0 times log 10 base 10. That's 0 times 1, and that gives us 0. Minus, here in this case, what's logarithm of 40 to base 10? I really have logarithm of 4, but I don't have 40. So this is what I'm going to do. This 40, I will break it down to 40 to 4 times 10, such that I can easily see log 4 to base 10 as what it is given here. So I have 0 minus logarithm. Mind you, there's a negative sign here, so put this in a bracket. So whatever I want to work for now is logarithm of 4 times 10 to base 10. And this can be expressed as logarithm of 4 to base 10. I want to use the idea of multiplication law of addition law of logarithm. I have log 4 to base 10. If I have multiplication, it turns to plus. And I have log 10 to base 10. So that means whatever I have inside this bracket and whatever I have here are still saying the same thing. So I will have a negative sign. I will have log 4 to base 10, which is given as 0.6021, then plus, finally log 10 base 10 is 1. So if I decide to add this and this together, this plus 1, that is 1.6021. So the final answer is minus 1.6021. So that's the correct answer to the question we have above. As you can see, it's clearly seen here. Find the value of can you see that it's not really clear? I don't know why it is not clear enough. So you can see that now. Find the value of logarithm of 1 over 40 to base 10 given that this. So the correct answer is C. So the correct answer is C. So let's check what the correct answer is. Show explanation. So as you can see, it is solved. The answer is 1.6021, so it is correct. So you can try more questions. We have several questions on logarithm, which does not require calculator. At least you just have to break it down, then get your final answer. So let's try more questions. Here in this case, we also have another question which says that we have to. Okay, let me give you this. Let's simplify this question. Logarithm of 49 raised to the power of a to base 7 minus logarithm of 0.01 to base 10. So whatever this is going to be is, I always tell you one thing. Remember the base. Just check the base first. I have 7. So can I break this down to 7? If yes, then you go ahead. So I have logarithm to base 7. This 49 is 7 raised to the power of 2. Mind you, we still have a. That's 2 times a. That's 2a. Then minus logarithm to base 10. This 0.01 can be expressed as a fraction, and that is 1 over 100. So the next thing for us to do from here is these two a's. You just use the rule of power law of logarithm. This comes down. Then you have 2a multiplying log 7 to base 7 minus logarithm to base 10. This 1 over 100 is power minus 1. Do you agree with that? So that's how it works. So log 7 to base 7 is just it is 1. So I have 2a left minus this is minus 1. When this minus 1 comes down, I have minus 1 there. So I will be left with just 100. Do you understand that? And then I have 2a. What's minus times minus 1? That's plus 1. That's plus logarithm of base 10. This 100 is 10 squared. 100 rather. 100 is 10 squared. So I end up having 2a plus. This 2 comes down. 2 log 10 to base 10. Hence, the final answer here is 2a plus. Log 10 base 10 is 1. The correct answer is 2a plus 2. So you see, this question here is different entirely from what we have been solving so far. Okay, so this gives the correct answer to the question we have up here. As you can see, here are the options. What is the logarithm of this minus this? Then you have option A, B, C, D. So the correct answer is D. So that's how it works. Let's try another question. Consider this. Simplify logarithm of 8 to base 10 over logarithm of 4 to base 10. So here in this case, please, mind you, you have to take note of this. Don't even try to, do not make attempt of cancelling this and this. It is not allowed. No. You can only cancel this logarithm with this base if and only if you have already expressed the logarithm value in index form, which is 2 raised to the power of 3. That will give us the 8 we have there. And this is also 4, which is 2 raised to the power of 2. This 3 comes to the back. You have 3 logarithm of 2 to base 10 all over. This 2 comes back, 2 log 2 to base 10. So you have to be very careful. You can't cancel from here. And you say 8 over 4, then you say the answer is 2. The funniest thing is that you see 2 in the option, and that's very, very wrong. So here in this case, whenever you notice that the logarithm value and the base, if they are the same for both the numerator and the denominator, then you can say that yes, this can cancel. Log 2 base 10, log 2 base 10, so you can cancel it. But here, log 8 base 10, log 4 base 10, they do not look alike, so they can't cancel. In fact, ordinary log base 10 will not cancel each other. It's not possible. So whatever I have left here is my final answer. That's 3 over 2. So be very careful. If suppose you have already cancelled this and you end up having 8 over 4, I'm very, very sure that from the option you might end up seeing 2 in the option. Option B, you see 3 over 2. So as a normal student, you just go ahead and pick 2 by cancelling this, and then 8 over 4 is 2, and that is totally wrong, unknowing that 3 over 2 is the correct answer. So let's just check the option. So from the option I have here, as you can see, simplify log 8 base 10 over log 4 base 10. Then you see option A is, you see option C is 3 over 2 and option D is 2. So they want to convince you. The correct answer is C. So let's try to view the explanation to check what is the correct answer, whether it is 2 or 3 over 2. So the correct answer I have here now is, so as you can see, I'm coming. Oh, so as you can see, what we have here now is, you see, 2 is power of 3, 2 is power of 2, then you have 3 over 2. So the correct answer is C for that question. So do you understand now? So that's how it works. So I've solved enough questions on logarithm. Let me just take one more. Let me try to take one more question, just one. Then we stop. Um, Suppose we have the logarithm of 27 and then we have square root of 9. If you have something like this, then how will you evaluate? Be very careful. This is 27, this is 9. Now my question is, I used to say that consider the base and consider this 27. Can I break this one down can I break this 27 down to 9? No. But I believe that this 9, I can break it down to 3. I can break this one down to 3. So that's what I will just do. Here in this case, this 27 will be 3 raised to the power of 3. Do you agree with that? And this square root of 9. Remember from indices, I said there's an invisible 2 here and there's an invisible 1 here. This implies 9 raised to the power of 1 over 2. Do you agree with that? The numerator over whatever you have here. So from the law of logarithm, we actually have power of base law. Power of base law says that if you have power on the base, what happens? It becomes a reciprocal, 1 over 3. Then what do you have left? Logarithm of this 9 becomes, okay, let me write it out first, to base 3. Then whatever you have to do from here now is logarithm to base 3. This 9 is 3 square. And the square is still multiplying a power over there, which is 1 over 2. 2 cancel 2. I have 1 over 3 left. So I have log 3 to base 3. This is 1. Final answer is what? 1 over 3. So I've solved more than enough questions on logarithm. So I'll try to look for more questions and then send it to you guys, so you go ahead and solve them. Okay, so the next topic I would like to just consider is the sequence and series, whereby we talk about arithmetic progression and geometric progression, the sum of AP, the sum of GP, and then finally talk about the sum to infinity of GP. So guys, thank you.